So this is AEGIS, uh, our proposal for challenge 13, that was air gap predictive profile for secure MPLS operations. So quick context. NOC teams today only find out that something is broken, something is wrong with the server after it's broken. Aegis watches the trend and warns them before that happens, which happens fully offline because this is built for networks that can't touch the cloud. So how does that work? How does this tool works is, here I will inject some random fault, and here you can see there are three branches, and for each branch there could be three problem in the network, that is utilization. Either the utilization can go uh, much more than they should be, like the traffic could go very high, or there could be packet loss or jitter, that is inconsistency in the information. And packet loss means the network is has started dropping off packets at a very fast rate, which is causing problem in the server, in the network. So before that, one important thing which I want to say is that neither I nor the dashboard knows that there is some what advanced problem it will create. The server picks it up internally and it never tells the front end. So let me show you the demo first. So here I am clicking on the inject random fault button, and the fault is injected. We'll wait for it to predict. The copilot is here. It will show the diagnosis here in this dialog box, in this window, sorry. So here, as you can see, the problem is with branch 2's utilization. The confidence rating is there, and there is somewhat around 20 minutes, 18 minutes somewhat to impact. And as it crosses the threshold mark, it will already get in the breach zone. And along with the problem, the copilot, here you can see the 90% threshold is crossed, and the status shows already in breach zone. And along with the problem, it is also showing us the root cause, the problem, uh, the reason for the problem, and the recommended action which we can take in order to fix this issue. So here we can see there is sustained traffic growth without QoS prioritization, that is what kind of data is to be prioritized, which is to be passed over this tunnel isn't prioritized. It could be like there is some important video call or a conference call for the company's meeting, and there some backup data which is being passed through the same tunnel. And in that scenario, the conference call is to be prioritized, but both are being passed at the same rate. So in that case, what we could do is we could use some backup path. We could reroute the non-critical traffic. QoS prioritization is to be applied. Similarly, let us set it to nominal and check for another random fault. So here I am setting it to nominal again, and let me push some another random fault in the server. We'll wait for the numbers to climb up, and here this time it is a packet loss issue in branch 2. And as you can see, the confidence surge is surging up, and the estimated time to impact is decreasing somewhat at around 20 minutes as of now, 18 and 90. As it crosses the threshold, it is already in the breach zone as in the previous case. And similarly, it is telling us the root cause as well as the recommended action which the NOC operator uh, can take at the very moment. So repeated route withdrawal and re-advertisement, uh, falling transceiver, that there could be a hardware related issue which is causing the problem. So recommended action, we can check physical link error counters, CRC drops, on the branch 2. And as you can see, we have also sorry, the copilot has also pointed out that there has been a similar issue in the past as well, a falling transceiver. So there was a hardware issue that time, a falling transceiver which was causing intermittent physical link drops. And so here it is for in case of packet loss. Let us see if it catches some jitter problem as well. Then I'm setting it to nominal and injecting some random fault once more. So let us wait for the numbers to climb up again and some problem to show up. Yes, so there is this time a jitter, that is inconsistency in case of branch 1. So again you can see IPsec tunnel degradation in branch 1, rising jitter machine runbook 003, 90%, 90%, the threshold is crossed, and it's already in the breach zone. So it could be an MTU mismatch introduced after a CE router firmware update, which happened earlier in March 2024. MTU settings, so it is also telling us the recommended action which we can take place before. Yes, so that's it. And I want to tell you that there is a Python script which is acting in the backend, which is generating these telemetry data, these telemetry figures, over which the frontend is acting. And let me reset it to nominal, and here, that is it. Thank you.